Hello and welcome to the C++ Insights YouTube channel. I'm Andreas Fertig. I work as a C++ trainer offering classes worldwide, on-site or remote. This is my YouTube channel where I use my tool C++ Insights to teach you various topics related to C++. Welcome back to the channel. Today I want to illustrate why noexcept is crucial when it comes to move operations. Have a look at this. I have a class apple here. Apple comes with a bool that says poisoned and a unique pointer storing some memory on the heap and a second data member length here to have two of them. Apple comes with a constructor that takes a value for data and length, constructs a unique pointer here of int and assigns the data, and it assigns the length. I tried to reduce this example as much as possible, so I would not allocate an integer, a single integer on the heap if not really necessary. Assume that we are allocating an array here or whatever that suits the needs for a heap allocation. I also downstripped it to simply care about the move assignment operator here, taking an apple ref HRS here. I'm doing a swap of the unique pointer from myself to the right-hand side object, and this is the special poisoned variable here. If that one is true, the object throws an exception during move construction. My M poisoned here, after passing it the first time, automatically activates the throwing mechanism. The second time we do an assignment to the left-hand side. Then the length gets swapped as well. So what's crucial here? My move assignment operator requires two steps. If we take this throwing out of the picture, it requires assigning or swapping the pointer, so the dynamic memory, and assigning an integer. This is very often what you have in your types. If they are movable, they come with at least one pointer to dynamic memory, but they also often carry extra information, like what's the size of the data that we allocated on the heap and how much fill this did stuff, things like that. So it's, I would say, rarely a single pointer. And this is what I'm trying to illustrate here. We have two steps. If something happens between step number 1 and step number 2, like me throwing an exception here, well, then we have a broken object because we already swapped the data, but we didn't manage to swap the lengths as well. So we have dynamic memory and the length doesn't match the actual data anymore. Now I have two member functions to access data and length here just to get our hands on the values there. And then down here I have a downstripped version of std_vector, a really downstripped version. But vector is a perfect example for why we require noexcept here. std_vector takes the liberty to also use a unique pointer, and it stores a T array here in mdata. I simplified this vector a lot. Let's start looking at pushback, which is assigned from the array index operator, the only function that we have in this class. So if mdata is a null pointer, then I'm allocating new memory, an array of type T of size 1. I'm assigning the current value or forwarding it to the freshly allocated memory at position 0. And then otherwise, and this is obviously not great code, but I wanted to minimize the cases, I assume I do a second pushback. I allocate a new unique pointer array of T with size of 2. I'm moving the currently pushback value to the array at position 1. And then I have the data left over in the old array here, and I need to transfer that at position 0, right? This is what std_vector has to do whenever your pushback needs to reallocate. It has to take care of the already existing elements. And since you want to be very performant, you don't want to pay for a copy here, so that data should be moved. So this is what I'm doing here. I'm moving the data. In a final step, I'm assigning the freshly allocated data array here to the member variable mdata. That's all. So that's roughly how a std_vector works. Now below I have the following. I create a std_vector of apple. So this is the class I showed you previously, right? The class that can throw. And I'm doing the first pushback with apple and a value for the int and the length, which is totally bogus. And then I'm outputting the data. We can see, yeah, everything in my self-made vector here, that's intact. It's 4 and 35, perfect. And then I do a second pushback. And now this is the beauty about C++, right? We can try to push back. And what a standard library gives you as a guarantee is the strong exception guarantee. And that says that if that pushback here in line 67 fails, your original object v is still intact. And that's a very brilliant rule, because if that would be not a case, then what would you do with v? If you're trying to catch this, if you catch it in line 69, but you're in a deep call stack and you got that object from far above via reference, how do you tell the original owner that the vector just broke, right? So writing code without the strong exception guarantee would be something really, really difficult. And this is why we have that in place, at least for the standard library. That means for a regular string vector, if that operation fails, v is still intact and still has this value here. Sorry, not the exception code, the value 3 and 5. So that would be having that in place here after the exception try catch block. If I uncomment that, you can see, well, it terminates here. This GCC I am using, and it has an insertion going on. You can see it here. It says that get is not equal my pointer here. So presumably I am looking at a null pointer, which is understandable because the trick I made is, so the first assignment here, when I create the first object, it gets move assigned because it's temporary to the vector's first element. But the moment it does, it turns on the poisoned flag for the next round. And the next round is the second pushback when I'm trying to assign it to temp at position 0. Because I'm moving here, so that would kick in that operator. This is where things then break, because an exception is thrown. And I never write to this element at position 0. That also means that the following code here never gets active, so I never move the freshly allocated memory to mdata, so mdata is the original one. Problem is, the original one just lost its data, because we moved it away. This is why things crash here. This is basically why we need the noexcept here, because with the noexcept, the code would, in my case, fail at a different position, right? So that would directly call terminate and my program would be terminated. But that's not the end of the story. Like this content? Your company can hire me to teach a C++ class with even more details answering your questions. Feel free to reach out. Okay, so what do we have to do to make the thing work, or what does the standard library do? So first thing is I have to implement a copy assignment operator here, making Apple copyable. Then the vector implementation has a check that checks whether the T for the vector is no through move assignable. And only if that's the case, move is in place. Otherwise, there's a fallback to copy, because this is the only sane operation that you can do when you know that move could throw, because this breaks your initial object. Now what that means now is, if I put some output in here, that my code now copies the second time it assigns the value. The element at position 0 for the second pass, that one gets copied. Once I make my assignment operator, my move assignment operator here noexcept, then you can see I am crashing again because I still have the exception in, right? So let's remove that one. And now we can see this time I don't copy, I move, because now the machinery inside your container can be certain that either they fall back to copy and give you a safe mechanism to keep your vector v intact here, even if an exception is thrown and caught, or they know that the move operation is always safe, because even if an exception happens, the huge to terminate is getting called and technically your initial object v is still intact, because you never reach a point where you would get your hands on a broken one. This would be one of the functions inside a move operation could throw. I hope this also illustrates a little why you should always make certain that none of the functions you're calling in your move operations can throw, because move is a destructive operation and there is no rollback. What's the key takeaway for today? The key takeaway is mark your move constructor, your move assignment operator noexcept whenever you work with the standard library or any other decent library, because what they will implement and what you can implement if you're writing library code in your company is you should check whether a move is a safe thing to do or fall back to copy otherwise. With that, I think I can say without an exception, move safely and always take care of making things noexcept. That's it for today. Thanks for watching.